All right, it's Monty again, and in this video we are going to finish up what we were doing before. We talked about conditional statements and truth tables, and so now we're going to look at biconditional statements. All right, so let's get started. The biconditional statement, P if and only if Q, is symbolized in this way here. Basically what it means is that P implies Q and Q implies P. So we would say the implication is both ways. P implies Q, Q implies P. If P, then Q. If Q, then P. All right, so the biconditional statement is true when P and Q have the same truth values. All right, so we'll talk about why that's true, but let's go ahead and look at the table here. So both P and Q need to have the same truth values. So true, true, that's going to end up in a true statement, and false, false. In the other cases, we'll have a false statement. And basically the idea is, remember, the implication should go both ways. So if you have true, false, and you change the order, you would have false, true. And false or true, false is false, a conditional statement that's true, false. But if you switch this false, true, that's considered a true statement. Q implies P. And so they're not going to have the same truth value. And it's similarly true in this case here. False, true is true, as if you think of P implies Q, this would be a true statement. But if you switch the order here, you would end up with true, false. And so Q implies P would actually be a false statement. And so for that reason, the only time we have P if and only if Q is if they're both true or they're both false. All right, so let's, I do want to make one comment here. You may run into a question where it talks about P and Q being the component statements, which are basically the statements that make up this compound statement. All right, let's move on to the next slide or page. So here we have, we're supposed to evaluate the truth of the following statements. So we're looking for either true, true, or false, false in order to get a true if and only if statement. So Mr. Smith teaches at Brookhaven, that's true. Mr. Smith is a Texan, that's true. And so we have the same truth values. This is a true if and only if then statement. Greg Abbott is the governor of Texas. We said that's true. Lionel Messi is the U.S. president. That's false. And again, they don't have the same truth values, and so this will be a false statement. Here we have pigs fly, which is false. If and only if ice cream is a healthy treat, which is also false. And so this is considered a true statement because they're both false. So if they're both true or the statements are both false, then the if and only if statement is true. All right, so I have a summary of our truth values. So we have talked about not P, and the truth value of not P is the opposite of the truth value of P. For the conjunction or an and statement, P and Q is only true when both P and Q are true. For the disjunction or an or statement, P or Q is only false when both P and Q are false. For the conditional, we said P implies Q is only false when P is true and Q is false. And finally, for the biconditional, whoops, I guess I missed something there. P if and only if P is true when P and Q have the same truth value. All right, so that's a summary of all the truth values that we've looked at, the main ones. All right. So let's go ahead and look at example 6. It says construct a truth table for P and Q if and only if not P or Q. Now you can see that here I didn't put in all the headings for you. You've got to build this statement yourself. And so you may want to try doing that and then watching the video. This is something that takes a little bit of practice, and so I'd encourage you to try it first and then watch the video. Make sure you use pencil. All right, or maybe do it on another paper. So let's see. So first of all, don't I need P and Q? We already have each, P, Q, and R. So we're going to need P and Q, so let's find that first, the truth values for P and Q. Well, we know P and Q is usually false. It's only true when both statements are true. So we're looking at these two here. So we have true, true here, so that's true, and true, true here. And then, but not here, so this is false, 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 and false. And so there's two trues. There's only twice here in this column where you have true, true. All right. So now notice we're going to need to find not P or R, but we don't have not P yet, so that would be a good thing to find next is not P. So not P is going to be the opposite truth values of what we have for P. So it'll be false, 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 and then 4 trues. Now when you're doing this, you got to be really careful that you don't make a copy error. You just got to pay attention to the details here. I mean, all I'm doing is changing these 4 trues to 4 falses, and these 4 falses to 4 trues. Okay, so we've got the not P, but we need the R. Now, we could go back. We could just, let's see, we're doing a union or an OR with this column and this column here. So that's the way I like to do it. I think we can do that. It doesn't matter which one comes first. Notice it's R or not P. It doesn't matter the order here. We just know that an OR statement is usually true. Let me go ahead and write not P or R. So that's what we're finding now. And so we're looking at these 2 columns here, and we want to see, let's see, we know that we're going to be false when these are both false. So here, here, it looks like that's the only time. Let me just double check. Yes. Okay, so again, we're looking at these 2 columns here. So true, false, that's true. True, false is true. Again, if one of them is true, at least one, then we're set. Here we have true, true, so we're certainly true there. False, true, or true, and true, true, and false, true. So each of these is true. Again, we were only false when we had false, false, when both statements were false. So an OR statement is only false when both statements are false. So finally, we're going to do this final statement. We have, notice we have P and Q, and we have not P or R. And so basically, we want to go from here to here. We're looking at basically these 2 columns here. And let's go ahead and write the whole statement. It's P and Q if and only if not P or R. So that's basically our last column. So if they're both true or both false, it'll be true. So here we have true, 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 false, so that's false. False, true, that's false. Here we have false, false, they're both the same, so this is true. Here we have false, true, so that's false. False, true, that's also false. False, true, that's false. And false, true is false. So let me just double check here. All right, so this is our final answer here, and that's how you would do that. All right, let's go to our last page. So it says, write the statement in symbolic form. B, construct a truth table for the symbolic statement in part A. And then C, use the truth table to indicate one set of conditions that makes the compound statement false, or state that no such conditions exist. Okay, so here's our statement, our compound statement. If you do your homework right after class, that's going to be our statement P, then you will not fall behind. All right. Now, when we make these statements, P and Q, we want them to be positive. And so statement Q will actually be that you fall behind. So you do your homework, that's statement P. And this is basically a not statement. The positive statement is what we want to write for Q. You fall behind. Let's just say in class. All right. And so we want to write the statement in symbolic form. If you do your homework right after class, whoops, I should have wrote a little more here. Right after class, so we have an if-then statement. If you do your homework right after class, so that's P, and this is an if-then statement, then you will not fall behind. And so this would be not Q, because Q is that you fall behind. The statement is that you will not fall behind. And now notice there's a comma here that indicates that this is a statement that we want to put parentheses around, and then we want to use the and symbol. If you do not do your homework right after class, so that's not P, and then again this is an if-then statement, not P, then you will fall behind, which is Q. You will fall behind, or you fall behind. So this is basically not Q. If you do not do your homework right after class, that was not P, then you will fall behind. That was Q. All right, so when we put it all together, we get this statement here. So this is what we want to find a truth table for. So again, I would encourage you to see if you can do the truth table for this and get to that last column, and then watch the video. Okay, let's go ahead and do this. So let me just write this right here. P implies not Q, and not P implies Q. All right. So first of all, I need to put together this statement here. Well, I have P, but I don't have not Q, so I need not Q. So that the truth values here will be false, true, false, true, the opposite of what's here. And now we can put together P implies not Q. So I'm looking at these two columns here. So not this part here. So let's go ahead and write this. P implies not Q. Now we know that's only true when we have, I should say it's only false when we have true false. So the first one is true false. So this is false. We have true true, false false, and false true. So in all the other cases we're okay. We only have true false in that first line. And so our if-then statement is false, true, true, true. Okay, so then let's build the other statement here, the other conditional statement. So not P, we don't have that. We're going to need not P. So we're going to have the opposite truth values of what we have in P. So it'll be false, false, true, true. All right, and then we need Q. Now, if you want, you could just work kind of backwards here, but I think it's easier to just go ahead and put Q in here. I mean, I'm basically redoing a line we already have or a column we already have, but it'll make it a little bit easier to put it together because we want to look at not P implies Q. So not P and Q. Now remember, not P will imply Q when we have every case except for true false. And so here we are true false, so this is a false statement. There's no other true false statements, and so these are all true. All right. So finally, we can put this all together. We already have P implies not Q, and we have not P implies Q. So I didn't leave myself a lot of space here. So we have P implies not Q and not P implies Q. That's what we're looking to find. So we're looking at these two columns here. So let's go ahead and just mark that out. So basically we have an and statement with these two here. So that's how I like to show that. And so I'm just looking at this column here and this column here. And we know an and statement is usually false. It's only true when both statements are true. So we have true, true here. And we have true, true here. And here we have false, true, and true, false. So these are false. So again, the only time we're true is when both statements are true. We actually have two cases of that. All right. So finally, we're not quite done. It does say use the truth table to indicate one set of conditions that makes the compound statements false or state that no such conditions exist. Let's see. That makes this compound statement false. Well, it's false. It's false. So this is C. False when P and Q are both true. Notice the other thing we could have said is it's false when P and Q are both false. So we could have said P and Q are both true or both false. That's when we're false. All right, so we actually have two cases where this is the case, where we have case 3 where the compound statement is false. All right, well, that's the end of this video. I hope that helps, and if you have any questions, let me know.